Hello and welcome to our continuing lesson on conics. Up to now, you've seen the conic shapes in equation and graph form. They are called a circle, or which is really just a special case of an ellipse, a hyperbola, and a parabola. You've worked a fair amount with parabolas, I think, maybe somewhat with circles and ellipses. And then there was a lesson available to take a look at for completing the square. It was a quick review. Today we're going to take those skills, the familiarity with the equation in the right form and how to complete the square to get it in that form, to create an equation that's easily graphed when it's in standard form. We can find the key information, center, radii or radius, asymptotes, that kind of thing. So let's get going here. One of the things you're going to notice is that the form, for instance, of a circle or an ellipse or hyperbola all have the x and y on the same side. So the standard form looks a bit different than what you've gotten familiar and worked most with in a parabola. Parabolas have a linear x or y set equal to a quadratic x or y. But for today's lesson, working with circles, ellipses, and hyperbolas, we're going to like this standard form that has both variables on the same side. So we won't have any linear terms only. They'll all be x squared and y squareds that we'll have to work with. And the parabola work is left for a separate lesson. Now what I want you to notice is that the new form that we're going to want to work with, the form that's not as useful for parabolas but is useful for ellipses and hyperbolas, has the constant over on the right side. So we don't have to worry about adding or subtracting from there. Now we can focus on completing the square. For instance, in this case we have an a of 5. We need to factor that out of both variable terms. When we do that, we're left with x squared plus 6x. And now we want to think, how do we complete the square x squared plus 6x? Well, this 6 comes from doubling, so we're going to cut it in half and square it to add a 9. And remember that this is really a 5 times 9 we've added on the left. We're going to add 5 times 9 on the right. Typically, you've subtracted that from the same side. It's the same idea. We're going to add it to the right side of this equation. To complete the square, x squared plus 6x plus 9 is simply x plus 3 squared. And the right side is just going to be a constant. 7 plus 45, 52. Okay? So that's going to be a significant skill that we'll deal with today. Consider both variables that need work and how that is going to show itself in an equation. We're going to determine whether an equation represents a circle, ellipse, hyperbola, or parabola. In today's lesson, we will not deal with parabolas. That'll be a separate lesson. We'll complete the square, and that is going to be required on both x and y. So there's going to be it's like two problems in one to create this new standard form. The standard form you may have been familiar with for circles. And then we just find the key information and sketch the graph. So here we go. Complete the square, then find the center and radii or slopes of the asymptotes of conics. So we're going to complete the square for both x's and y's. And a good skill here is to identify the x terms, pull those off to the side, and the y terms. This constant, we're going to want to throw that over the other side. So in the very first step, we have the x minus 2x, or x squared, the y squared minus 2y, and then the constant over here on the right. And now let's work the problem. Half of negative 2 is negative 1. Squared is a positive 1. If I add it to the left, I need to add it to the right. Half of negative 1 again is negative 2 is negative 1, and squared is positive 1. We add that to both sides. And we have an x minus 1 squared, y minus 1 squared equals 3. And what this allows us to see is that we have a center of 1, 1, and a radius of square root of 3. I'm going to go over to graph that. I'm going to move 1 to the right and 1 up, put a dot, that's my center. The square root of 3 is some number between 1 and 2. We're not going to get too worried about that. So it's some number bigger than 1, less than 2, and we'll put dots. and prove I'm not an artist. There you go. You have a circle centered at 1, 1 with a radius of square root of 3. Okay, and now we're ready to work a very similar problem. The key thing to notice on this problem is that the coefficients of x squared and y squared are now different. That means it'll stretch differently vertically versus horizontally, and because they're both positive, it'll make an ellipse. So our first step, though, starts off very much the same as the previous problem. We're going to create something that we can complete the square for on the x's, putting in a space there, and the y's. And we'll add the 9 over to the other side. Continuing, we'll factor out a 3. Now I'll complete the square here. Half of negative 2 is negative 1. Squared is a plus 1. That means I've added a 1 times 3. So I need to add 3 on the right side as well. Similarly, my y squared has to have the 4 factored out, leaving y squared minus 6y. Plus half of negative 6 is negative 3 squared is 9. And that means I'm adding a 36 for a total of 48. Now I've got my perfect squares. What I can do now is divide both sides by 48. And that gives me 3 over 48. And 3 goes into 48 16 times. So that'll be an x minus 1 squared over 16 plus 4 over 48. 4 goes into 48 12 times, leaving y minus 3 squared over 12, and that equals 1. And I want to get my denominators inside that square, so x minus 1 over 4, that worked out nicely, and the y minus 3 not so much. Square root of 12, some number between 3 and 4. But I do know how to read this, giving me my center of 1, 3, horizontal radius or stretch of 4 vertical of square root of 12. And when we plot our point 1, 3, we'll move left and right 4, and then up and down square root of 12, which is somewhere between 3 and 4. And so a very slight, but hopefully noticeable horizontal stretch. This one's a hyperbola. I know that because I see a negative in front of the x squared. Completing the square will be very similar, but negatives cause a little bit of a problem. So I'm going to rearrange first. Negative x squared plus 4x. And then we'll have something plus y squared plus or minus 4y plus something equals 1. I'm going to add that 1 over to the other side. And factor out an a. And in this case, the a, or the stretch factor for the x, is x squared is going to be a negative 1. I'll use square brackets. X squared minus 4x. Half of negative 4 is negative 2 squared is a plus 4. That means I'm actually subtracting 4 from the left side. Put a plus. This one has nothing to worry about. I have to add a 4. That allows me to write negative 1, perfect square is x minus 2 squared, plus y minus 2 squared equals 1. And now that we have this equation, we can tell our center quite easily. It's 2, 2. And even the slope is easy. We'll say negative 1 over 1. But the key here is the direction that our branches open for a hyperbola are going to be in the direction of the positive term, in this case the y. So it's going to open up and down these branches. So to sketch this graph, we'll simply plot the point 2, 2, and then go with slopes up 1 over 1 and up 1 back 1, and I always make dashed lines. And now our graph is going to exist just touching our little box here. and approaching these asymptotes. Okay. Graph the following. Okay, same idea. We're going to want to complete the square and separate x's and y's. Here we go. We'll take the x's, space. Now here we have a 0y, so we don't have to really do anything. We can put minus 0 squared when we're done. And we're going to add the 128 over. Completing the square for the x is the only real issue here. That comes from factoring out a 16, leaving x squared plus 2x plus half of 2 is 1, 1 squared. Of course, if we've added a 1 times 16, we need to add a 1 times 16 on the left. And here I can jump right to a y minus 0 squared, where this adds to, okay. So from this next step, I'm going to divide both sides by 144. What I get there is 16 over 144. Now that I don't know. 9. So what I'm going to get there is an x plus 1 squared over 9 plus 9 goes in 144, obviously 16 times. Oops. And then I get my 1. And to put the 9 and the 16 in, I have to square root them, put them inside the squaring, so I get x plus 1 over 3 squared, y minus 0 over 4 squared. Our center, negative 1, 0, has a horizontal radius of 3, vertical radius of 4. So to sketch this ellipse, we'll plot the point 1, 0. We'll move 3 left and right, put a dot, and up and down 4. So stretched vertically, slightly. All right. Graph the following. We notice in this one it's going to be pretty easy to get things cleaned up. Looks like it's going to be an ellipse centered at this at the origin, but we'll do our work here. We have 25 x squared plus 9y squared equals 225. Divide both sides by 225. We have 9, so x squared over 9 plus, obviously, a y squared over 25. That equals 1. We can bring the 9 and the 25 inside by doing, and I'll throw in a 0 just to make our center obvious. You don't need to throw that in there. Center of 0, 0. Horizontal radius of 3, vertical of 5. And so from the center, there's our ellipse. And I think this one might be our last one before the on your own. So this next slide is the on your own. Graph the following, and we can tell this is going to be hyperbola, opening in the vertical direction again because the x is negative. So let's clean things up here. We got a negative x squared minus 4x plus something plus 24y plus 4y, whoops, 4y squared plus something equals negative 28. I've got to factor out the negative 1 here. Half of 4 is 2, squared is 4. I've added a negative 4, so I've got to add a negative 4 on the right. Factor out the 4 with the y term. Half of 6, 3 squared is 9. I've added a 36 on the left side, giving me a total of 4. I'm going to divide everything by 4 on the left and on the right. That gives me a negative x plus 2 squared over 4. Just a y plus 3 squared because the 4 over 4 cancels. And I can put that over 1. Now to bring the 4 inside, negative x plus 2 over 2 squared plus y plus 3 over 1 squared equals 1. And remember that this negative that sits out front cannot be put inside of a square. It's not like distributing when the quantity is being squared. If it was just an x plus 2, you could distribute the negative inside, but once we do some work on it like that, raising to an exponent, you can't just put it inside. And this gives us a center of negative 2, negative 3. The asymptotic slopes are rise of 1 over 2. We could call it negative 1 over 2. It doesn't really matter. So we'll put a dot at negative 2, negative 3. Go up 1, right 2. That's pretty lousy. Something like that. And now make our box 1 vertical. And that allows us to make our sketch, our actual graph, opening vertically, going through this point and approaching these asymptotes. Okay, so there you go. Give these a try. It's indicated what shape they should be, so that should help. Good luck, and we'll see you in class.